We're going to take a look at lesson 3.2. So this is all about translations. I don't know if you remember or not, but 3.1 and 3.2 were lumped in with each other. So these weren't kind of separate lessons. Of course, the videos were separate, but when it came to the check-in and the vocab and concepts, those were lumped in together. And it's because they were a little bit, similar. But also because the district wanted us to do them all in 1 week, but it was too much, right? I don't know if I said this at first when we looked at lesson 3.1, but keep in mind, if I'm kind of glossing over something, if I'm not explaining it in depth, then you're like, what are you talking about? Maybe go back to the actual lesson, like 3.2 or 3.1, and watch that video tutorial or look through the textbook and look at vocab words and things like that. And hopefully that will clarify, your questions that you're having. Of course, if it doesn't, reach out to me and I'm happy to show you another example or explain it in a different way. So 3.2 is all about translation. Basically, if you take a shape or a point or whatever you're dealing with, then you just slide it around the page. So translations is just about moving stuff left, right, up, and down. Pretty straightforward. A translation is a transformation, so it's just a type of transformation that maps all points the same distance and in the same direction. So that for any 2 points, A and B, A prime will equal B prime. So that's just saying that the distance is going to be the same. A translation is a rigid motion. Remember, that doesn't change the size of the shape, or the size of the thing you're dealing with. So if you look here, you're dealing with a little triangle and you still have a little triangle and they still look the same. So the size didn't change. It didn't get bigger or smaller. And didn't change all the angles. It still looks like angle M is pretty small. Angle N still looks like about 90 degrees, right? Angle L still looks like it's about in the middle, like it's 60 or something like that. So overall, I think that's a rigid motion. Any translation can be expressed as a composition of two reflections across two parallel lines. So what they're talking about there is if I take, this shape right here, and I reflect it across that first line, it's going to look something like that. Again, excuse the detail, but you could see that this kind of looks like, that's a right angle, I'm going to call it. So when I reflect it across that line, it gives me that shape right there. And now if I reflect it across the second line, well, these things do not look alike. It's going to give me that. Right? Imagine these triangles are exactly the same. So if I reflect it and then I reflect it again, notice that these two triangles look the same, right? At least fairly close. Again, excuse my details of my drawings. An example, what is the graph translation? That's what that T means. That's a translation. 3, -2 of triangle LMN. So the way to read this is the T represents translation. If that was an R, it would represent reflection. What this does is this gives me an X and a Y. So this X, that first number, is telling me how far to go left or right. Remember, on a coordinate system, these numbers, 1, 2, 3, that's the positive direction. Whoa. These numbers, -1, -2, -3, left is the negative direction. So when you're talking about left and right, when you're talking about the x-axis, left is negative, right is positive. And then with the y-axis, up is positive, down is negative. So if I'm looking at this problem here, what is the graph of translation 3, -2? That's telling me to go right 3 and down 2. So every point from that pre-image, L, M, and N, they're all going to go right 3 and down 2. So M goes right 3, down 2. L goes right 3, down 2. N goes right 3, down 2. So essentially what I did was I took that shape, I took that pre-image, and I took it and I slid it 3 units to the right and 2 units down. Practice and problem solving for exercises 12 and 13. The vertices of PQR are that. What are the coordinates of the vertices of its image for each translation? Again, there's kind of a simple way to think about this. There's a more complex way. You could draw this out and sketch it and actually move. You can plot each of these 3 points, move each of these 3 points left 3 and up 2, and then give me those new vertices. But what you're doing essentially is you're just kind of adding these numbers together. You're adding the X's, you're adding the Y's, right? You're adding the X's, adding the Y's. So that's kind of a shortcut way to do it. So let's go ahead and look at that. So for number 12, if these are my 3 points, and just to save time, I'm not going to rewrite these down, but if I have point P prime, all I'm going to do is add those values together. So if my X value was -4, I'm going to add -3 to give me -7. If my Y value was 3, I'm going to add 2 to give me 5. So P prime is going to be at -7, 5. And then Q. So Q prime, Q is at -2, 3. So if I add those X values and those Y values to that original point, -2 plus -3 is -5. 3 plus 2 is 5. So Q prime is at -5, 5. And then R prime, 1 plus -3 is -2. -3 plus 2 is -1. So there would be my image. So again, there's more complex ways of doing this. You can plot those points. You could actually slide them each and then, you know, identify what the image points are. But just adding those values is the simplest way to go. So for 13, now I'm going to move it right 4 and down 5. So -4 plus 4 is 0. Uh, 3 plus -5 is -2. Q prime, so -2 plus 4 is 2. 3 plus -5 is -2. And then R prime, 1 plus 4 is 5. -3 plus -5 is -8. What is the translation shown? So basically, again, we've already talked about this multiple times. This is my pre-image, this is my image. How do I tell that? Well, the pre-image doesn't have apostrophes and the image has an apostrophe. So it's important to know I'm going from this shape to this shape. That's going to change the translation values if you're going the wrong direction. So go from this black shape to this red shape. If this is an actual translation, then this shape, all of these points, all 4 of these vertices should move in the same direction. Up so many, over so many. So let's verify. It looks like T is going up 2, over 1, 2, 3, 4, 5. So since T is going up 2, left 5, all of these points have to go up 2, left 5. V has to go up 2, left 5. S has to go up 2, left 5. So what's the translation shown? For number 14, the translation, and I think they're giving us the quadrilateral, STUV. So of STUV, that translation again is going to be up to left 5. So up to left 5. You know, you could have just wrote this right here, 2, -5. You don't have to write it with that notation, but you know, it's up to you. Number 15, given reflections RH, R sub H, and R sub K, where H is aligned with the equation x equals -3 and K is aligned with the equation x equals 2, how can you determine the distance of the translation resulting from the composition R sub K to R sub H? Long story short, this is that problem where I'm just going to draw a picture because they're not actually talking about like a triangle or whatever, but they're talking about H and K are our 2 lines. So I've got this shape. I reflect it across line H. And then I take that shape and I reflect it across line K. Okay? Doesn't matter the shape. We're just reflecting across line H, then across line K. How do I know that I'm doing H first? Remember, this is a little bit weird. You're almost reading it backwards, right? You do this transformation first, then you do that transformation. So you're kind of working right to left. And then they're giving you values here. So they're saying H is x equals -3, and K is x equals 2. So long story short here, there's an algebraic definition, which if you want to look at it, I wouldn't recommend it because it's a little bit confusing. You can go back to 3.2 and watch the video, but here's the down and dirty, easy way of doing it. What's the distance that these two lines are apart from each other? Well, if this is at x equals -3, right? And then this is at x equals 2, those two lines, right? Those two lines are going to be 5 units apart from each other, okay? So same thing here. They're not even giving you a coordinate system. You can draw it yourself. You can draw something like this. You can just think about it in your head. How far apart are these two values? Well, on a number line or on a coordinate system, they're 5 units apart. Well, the easy way to do this is you just know that these two, this pre-image, so we'll call this triangle A, and then this second image, those two triangles are going to be 2 times the distance between these two reflection lines. So the distance between the lines of reflection, if one's at x equals -3, one's at x equals 2, those lines are 5 units apart. All I have to do is multiply it by 2. So I know from A all the way to A double prime, that thing is 10 units apart. From this side of the triangle all the way to that side of the triangle, that thing is 10 units apart. So that's the easier way to think about that type of problem.